Hello guys, today we are going to solve a LeetCode problem of 7th June. The problem is stated create binary tree from description. So we have given a description array where every element represent parent with their children and if the parent is left. So what is left is stated is left. The value of is left is if 1, then the child becomes the left child of the parent, otherwise the right child of the parent. Okay, so we need to create a binary key by using the description array and we need to return its root. Okay, so let's understand with example. So here description array have given and each one represent parent, children and is left or right. Okay, so we need to create. So first we will tables from the description and we will check. Let's create a node of 20 and 15 as the left child because its left value is 1. Okay, and we will push this 20 here, which will point to the TreeNode of this 20. So okay, this 20 is actually a node and we will push the children in the set. Let push it 15 as a children. Okay, yeah, we have pushed 15 as a children. So now we need to traverse 2017 0. Okay, now we will look up in the map. Is there a node already existed with a value of 20? So it says yes, I have a node whose value is 20. So it will return a pointer of 20, that is this one, and we will also look for is there a TreeNode pointer for the 17 and we will find that there is no 17 exist in the map. So we will create a new node and we will also push it here 17 comma 17, which will point to the pointer of the 17. So we already get 20 pointers and we will attach as a right node because its left value here is 0. Yeah, and now we will traverse in the third one this. So we will first look up is there any node of 50 in the map. So as there is no node, so we will create a new node and push it into the map that we are doing. Okay, and we will also look if there are 20 in the map. So it said yes, there is a 20. Okay, so in the last operation we also need to push 17 because it is a children, and so we will also got the pointer of the 20 and also got a pointer of the 50 that we have created. So we need to create a 50 here. Let me move it. Yeah, so we need to create 20 as a left child of 50. So we will create it as a like this one. Okay, now we will traverse forward and we will find is there any pointer of the 50. in the map, it says yes, I have a pointer of the 50. It will return it, and we will also look for the 80 is there, and here we will push 20 for our last operation, and we will look is there any pointer of the 80. So it says no, there is no any pointer, so we will create a pointer of the 80. Okay, after creating a pointer of the 80, we need to create a children of 50 as 80 as its right child. Okay, and we will push 80 as it is a children of 50, and we will move forward, and we will look is there any pointer of the 80. It says yes, I have a pointer of 80. It will look is there any pointer of the 19. It will say there is no any pointer, so we will create a pointer of 19. Okay, so we will create a pointer, and we will, and 19 is the left child of 80, so we will create it as it, and we will push 19 in the set because it is a children node. Okay, and we will now traverse the whole map array, and will look if this node is a children node. We will look for 20 if this is a children node. So yes, this is a children node. We will look for 70 if this is a children node. It says yes, it is a children node. We will look for 50 if this is a children node. It will return that there is no any value contains 50, so it is definitely going to be my root. So we will return 50 as a root node. Let's get into the code, and you can check that this is a 50 node and we have taken this as a root. So let's get into the code. We will create n as a description size, and we will create a map of int and TreeNode pointer. It will point for a value, integer value, to a node pointer. Okay, and we will create a set data structure to check whether it is a children or not, and we will here traversing the whole array. We are taking the value of parent, children, and isLeft, and here what we are doing if there is a already p existed in the map that we are looking for it. So if the pointer existed in the map data structure, so we will returning it. So here we will checking it, and if it exists, so we will returning of it. Otherwise we will create a new pointer. Same for it. If it is not in the map, so we will create a new children node. Otherwise we will return the pointer of the children node. Okay, now we are looking is the value is left. If is left value is 1, so we are creating the children node as a left of the node. So here node left value contains children pointer, and here otherwise node right contains children pointer. And here what we are doing, we are doing mp of p is equal to node, means we are assigning a value of integer value to its pointer. Okay, and we will same do for its children, so that we will always find a node pointer for an integer value here. And at the last we are inserting adding a children array in the set data structure to find out at the later whether this node is a children or no or not. So at the last we are traversing our math data structure, and we will find if this integer is a children node or not. This integer is a children node or not. If yeah, it there is an entry in the set data structure, then it is absolutely a children node. So we will only look for if there is a no entry st.end pointer. So we will return the pointer of the that node, that is m.second, and this is going to be our root node. Otherwise we will return null pointer. Okay, so when this will comes into the picture, when the n becomes 0, means there is no description array, so we will return null pointer. Okay, let's run it, and yeah, it just accepted, and let's submit it. Yeah, it is working fine, and I have provided this code here. So this is the platform deployed on the render. So because of cold start, it is taking a little bit of time, and I have updated daily LeetCode column and geese for geese problem here, and you will find the solution here, and it is loading. And I will also add this link in my description. You will check it out and find the solution. So here I am going to update the 7th June problem. It will currently contain 6th June solution. Now we are moving for, yeah, this is a solution for 7th June. You can check it out and use it. So this is a platform. You can also share here your notes, PYQs, previous year question paper, that you can share it with your college peers. And have a good day. Thank you for watching. Please like and subscribe.